I want to find area between two curves. What you do to find the area between two curves, what you have to realize is you have two curves. If you have a graph, let's say you have this graph and this graph. I want to find the area between the two curves. This is always your f of x. The graph on top is always your f of x. The graph on bottom is always your g of x. If I want to find the area between two curves, you're always going to take f minus g, because you're taking the area of f of x minusing the area of g of x. You can think of it as two separate integrals, but it's easier to write it as one. And a to b is this is a, this is b. A to b is the interval for where they intersect. F of x is the top equation, g of x is the bottom equation. Basically, f of x will always be greater than g of x on the interval a to b. Okay, so depending on the graph, depends on which one's f, which one's g. F means the bigger one, g means the lower one. And you integrate it, and that will give you the area between two curves. So if I want to do this problem, I first have to find out where a and b, where it crosses. To find out where this crosses, you set them equal. Okay. When we set that equal, we now are probably going to try to do factoring to solve this. So we minus every, actually I'll move it all this way to get rid of that negative in front. So I get 0 equals x squared. When I minus this over, it looks like I get minus 3x. And when I minus this over, it's gone. And to solve that, that looks like it's going to be 0 equals x times x minus 3. Pull the GCF out. So x equals 0 and 3. You set each piece equal to 0. Okay. Now if we made a quick sketch of this graph, real quick, it just helps to make a quick sketch. What's going to happen? At 0 and at 3, these two graphs hit. All right, you're going to have a graph like this, and it's going to hit at 0, and it's also going to hit at 3. This is 3. It's going to hit here at 0, and it's going to hit at 3. Now, why did I know the parabola was upside down? It was negative. It was sad. This is a line. This is a sad parabola. It hits at 0 and 3. So at 0 and 3, it hits. And we're going to be finding this area right here in between. Now, do you also know by looking at the graph, do you understand that f, this is f of x, and this is g of x? The line is g of x, and this is f of x. So when we use this formula, we're going to take f of x minus g of x, the top minus the bottom. So is f of x going to actually be f of x this time? Yes, because f of x is the parabola. It's on top. G of x is on bottom. Now, I gave you this graph. Some of you could actually tell by looking at it what the graphs look like and make this prediction. But let's show you how you would do it without the graph. You need to be able to do it without the graph. And the way you simply do that is choose a number between 0 and 3. Plug it into both equations. I would try choose 1, the easiest number I can. So if I find f of 1, when I find f of 1, I get f of 1 equals, looks like I have 3. 4. So f of 1 is 4. Now, then I do g of 1. You're the same number. That would be 1 plus 1, which is 2. Which of these is bigger? F of x is bigger than g of x, so that proves f of x is always going to be on top of g of x. So, what I do now is I make my integral from 0 to 3. That's where they hit. And according to these two numbers, I know f of x is above g of x, so I'm going to take f of x, which is negative x squared plus 4x plus 1, I'm going to minus g of x, which is x plus 1. I'm going to integrate this. Now, could you just take each one individually and subtract the two answers? Yes. But could we also just change this into a nice, easier equation and just do it once? Instead of doing two integrals, we can make one integral. So we now have, from 0 to 3, it looks like we have negative x squared still. Minus this over, we have positive 3x. And minus this over. Okay, does that look right? Looks good to me. Running out of space, but if we want to solve this, we integrate it. So this would be, integrate this, would be negative x to the third over 3 plus 3x squared over 2 from 0 to 3. Now I want to find the area between this value. I want to find this value. So plug in 3. It looks like we got a negative 27 over 3 plus, looks like 27 over 2 minus, isn't this going to be 0 when you plug in 0? This one's going to be 0 when you plug it in. So it looks like here's my answer. I just got to get a common denominator and so forth. So my answer, when you multiply looks like 3 times this one, 2 times that one, get a common denominator. It looks like it's going to have a common denominator of 6. This one's going to be 2 times 27, which is, if we want to add these, one has a 3, one has a 2. Do what? Oh, this one, what's this going to become? This becomes a negative 9 plus 27 over 2. Is that what you're saying? Which that then becomes, looks like negative 18 over 2 plus 27 over 2, which is 9 over 2. There's the area between the two curves.